Okay. All right, so let's get started. And let me zoom in. All right, so we're only gonna do the first 2 pages, and just a bit of review. And hold on a sec, let me go to annotate. Oh, geez, hold on, let me zoom out. Okay. Hold on, there we go. I'm gonna do it like this, that'll be better. There we go, okay. Okay, so this title is called nth roots and rational exponents. It sounds kind of fancy. Before I get to the stuff up top, let's look at what you see down below. This stuff should be review from Algebra 1 when you guys were in middle school. Or maybe last year if you did Algebra 1, but you guys should be familiar with these properties. So if you see, first off, this is called the power. So when you see like something like a to the m, we see something like this here. This whole thing's called the power. So I want to make sure you guys are straight with the terminology because a lot of people will blur these terms. This whole thing's called a power. The a is called the base. The a is called the base. Does anyone know what the m is called? It's the exponent, good, yeah. So I want to just make sure we're clear on the terminology. So some people will say like a to the power, and the way you would say it, you'd say a to the power of m, right? Or you'd say a to the nth power. That's how we usually would verbalize it, right? And just so you know, the whole embodiment of it is called a power, right? This whole thing is called power. The a is the base, which kind of makes sense because it's like the bottom, like kind of like the basement or the base of a building. And the m is the exponent, it's kind of like extra, it's kind of like up there, right? Now, this property here, hopefully you guys remember this. Maybe I don't know, but we have 2 powers of the same base. Do you guys remember how to combine those exponents? Yeah, right. If they're being multiplied, you have the luxury of adding those exponents. Now, what if you have something raised to another power? You have a to the n and you have an n outside of parentheses. How would we combine these two? Multiply, right, exactly. Let me jump down to 5. What if you have 2 powers of the same base, but one's on top of the other? How would you combine these exponents? You subtract, exactly. Some other things that are good to know, if you have 2 numbers being multiplied, and then you have a power outside, you can distribute the power. You have the luxury of doing that. Or if you're dividing 2 numbers or 2 letters, and you have the power now, so you can distribute it. And the one thing that sometimes you just have to know, there's not really any rhyme or reason to it. If you have a negative exponent, it goes in the bottom. That you just have to kind of just memorize and know it. But the number 1 and 5 are pretty intuitive. You don't have to write this down. I'm just going to do it more for the sake of doing it. But like, what if I had 2 cubed times 2 squared? What is 2 cubed, by the way, if you were to work that out? 8. What's 2 squared? Oh, what's 8 times 4? 32. So that's pretty easy, right? And did I follow order of operations? Absolutely. I did exponents first, multiplication afterwards, right? I totally followed PEMDAS. But you could somewhat bypass PEMDAS by combining these exponents first. What if you add the exponents? What's 2 to the 5th power? If you multiply 2 5 times, 2, 4, 8, 16, 32. So you have that shortcut, right? So you have that luxury. So that makes sense. Or what if I had, now let me clear my screen. What if I had 2 to the 5th over 2 squared? Obviously that's 32 over 4, right? Which I know is 8. But can I subtract the exponents? Sure. If I subtract them, what do I get? And I still get the same thing. The way I like to think of this, like if you want to get to San Francisco, you can take Highway 101, which I think sucks, or you can take 280, which is a little nicer. So it's kind of like you have different pathways. You get to the same place, though. You get to the same destination, but you have different pathways. So that's what's going on there. Now, one thing I want to caution you about, please do not, this is the one thing, not many things irritate me. This does. 2 plus 3 with parentheses squared. What would that equal? Well, 5 squared, which is 25. Good. What some students will do, I hope you guys don't do this, is they'll do 2 squared plus 3 squared. You do that if you're trying to, right, if there's a multiplication in between, you could do that, right, right. If you had 2 times 3 inside squared, you could do 2 squared times 3 squared. Yes, that's right, Liz, you could do that. But in this case, you get a different answer, right? You get 4 plus 9, which is 13. It's kind of like in baseball, like when you get a base hit, what do? You run to first base, then the second base, and the third. But you don't run across the pitcher's mound and go straight to second base. Right? It just doesn't happen in baseball. That's what's happening here, is that you can't just jump to that, right? You have to follow PEMDAS, because what's the first step in PEMDAS? Parentheses, right? What's inside the parentheses? 2 plus 3, take care of it. What comes after the P? The E. Next one, take care of that. Then you're done. You can't skirt the whole system and say, well, I'm just going to go straight to distributing the exponent. You can't do it as a plus or minus. So please don't do that, because that's a mistake some people think they could do. But you can't, right? You just can't do that. Now, what makes this a little different, this section, and you can see with the examples, is that we have the exponents are fractions. So this is taking something you guys know and adding on to it. So we're extending your knowledge, right? This is the whole point. It's my job, right, as an Algebra 2 teacher, to extend your knowledge of what you've learned the last 3 or 4 years to this stuff here, right? So we're still going to be using the same properties. It's no different. It's just that the only difference that we're using fraction exponents. Now, what's the deal with fraction exponents? What's the story with that? So now we'll go to the top. So you see up top says the nth root of a number. Some of you guys are not, maybe you don't know, I'm not sure. Let's do something like this here. Square root of 25. So what is that going to be? 5. Now you haven't realized this, or maybe you have. It's the same thing as saying 25 raised to the 1/2 power. It's the same exact thing. Those are the same thing. So all along, radicals have been exponents. You may not have realized it, but they have been. Hopefully your Algebra 1 teacher mentioned that. If not, that's okay. We had a pandemic, we're getting over the pandemic, but they are exponents. Radicals are exponents, and more specifically, a square root is 1/2. There actually is an imaginary 2 here. We just don't show it. There actually is a 2 there. And we call that the index of the radical. That's kind of a fancy term. We call it the index of the radical. And what it means is that I want 2 identical numbers to multiply to 25. That's all it ever is. Like, what's the square root of 36? Because 6 times 6 is 36, right? Or what's the square of 100? 10 times 10. Now we get some weird numbers, like what's the square of like 22? I know it's like 4 point something, but the bottom line is that it has to be 2 identical numbers to multiply this. That's what that means. So that's just something to be aware of, that we want to be fluid with radicals and x. We want to be able to go back and forth between the two. They're interchangeable. So when you see something like this here, the nth root of a number, it's like saying a to the 1/n power, just so you know. It's the same exact thing. And n's called the index of the root or radical. Okay. Also, what this means is that if I multiply b n times, so another way of thinking about this too is this as well. b to n equals a. So for example, if I have the square root of 25, isn't that the same? We know equals 5 because what's 5 squared equal? Right. So this is like the a, and that's like the b. So if I raise b to the 2nd power, I get what's inside the radical, which is 25. Let's look at another example. The cube root of 125. Does anyone know what the cube root of 120, or want to take a stab at that? 5. Because what happens if you multiply 5 3 times? You get 125, right? It's true, because 5 cubed equals 125. And by the way, you could have written this as 125 raised to the 1/3 power. The reason why I'm showing you this conversion from radical to exponent form is in the calculator, right? Now, my real laptop, this is like my laptop I own, but my school PC, I actually have that calculator app, and unfortunately, this one does not have it. But when I do get my laptop back, I'll get later today, I'll show you in the TI calculator how you can actually punch that in. So you could punch in radicals too like this, that's possible. But at the same time, you could also just write that also. 125 and raise it to an exponent. So radicals can be written as exponents. Now, what we're doing in this particular section is using properties of exponents, right? As I discussed a few minutes ago. So let's talk about the properties down below. Okay, so let's take this one here. So you have a triangle times a triangle equals a to the 1 power. Okay. So what number can we use to represent the triangle? So if I think about it, how many of these powers do I have? 2. So I can actually add those triangles like that. Because you got 2 of them. So 2 triangle equals 1, right? Or what does a triangle equal? Yeah, the triangle is like a variable. That's all it is. It's like a variable. So a triangle times it, you have 2 of those, right? That's why it's a to the 2 triangle power equals a to the 1 on the other side. So therefore, if these are the same, the bases are the same, the exponent is supposed to be the same. So 2 triangle equals 1 or triangle equals 1/2. Let's try another one. Here you got a diamond. How many of these powers do I have here? 3 of them. So a3 diamond equals a to the 1. So 3 diamonds equals 1. Well, what's a diamond going to equal? 1/3. There we go. So as I mentioned, when you see this here, it's the same thing as that. Those are the same exact things. So the nth root, this is really the key concept right here. I'll put in a little star here. The nth root of a equals a. That's the whole essence of this lesson today. The nth root of a equals a to the 1 over n top. Because if you think about it, this a here, do you see an exponent next to the a? So when you don't see an exponent, what do you assume it is? If you don't see an exponent next to a variable, we always assume it's like if I have x, if I don't put an exponent here, I assume it's just going to be 1. Like if I have 2 here, if I don't put an exponent, I assume it's because it's still 2, right? So if we don't see an exponent, we assume it's 1. However, what if you do have an exponent? If you do have an exponent next to the a, in addition to the radical, this is also important too. That's also important. If you have a to the m over n, it can be written like this. So let me give you a good example. Let me think here. Let's do this. Let's do the cube root of 8 squared. Okay. This can be written like this. Oh, yeah, like that. Or it could be written like this. So those are all interchangeable. Here I'm squaring 8 first and cube rooting. Here I'm cube rooting and squaring. Those are the same thing. Those are totally interchangeable. That's why we're showing this 1 over n and n, or n and 1 over n. Those are the same thing with nth root n, or a to n and nth root. Or you can write like this. I much prefer this if you're punching in a calculator, because it takes a little more work to punch it in like this. A little easier just to write an exponent and raise it to 2/3. So you again, it's just making sure you're comfortable going back and forth between radicals and exponents. Those are the same thing. By the way, what is this? What does that equal if you were to work it out? 4. Good. Yeah, because what's the cube root of 8? 2, and then 2 squares. Or you could do 8 squared first, which is 64, and then cube root afterwards. Either way, you get the same thing. Personally, it might be easier to root first and then square afterwards, because taking cube roots of big numbers can be a little challenging mentally, but that's just 4, right? And by the way, if there's a negative exponent, not a big deal, just put on the bottom. Negative exponents, put them on the bottom, and then do the rest. Okay. So I think now we're going to do some examples, and you guys can do some practice in just a little bit. Okay, so again, we're doing this without a calculator. We'll have to use a calculator for parts D, E, F, but parts A, B, C are mental. We want to be able to do this without a calculator, and I know you guys can do it. So if you think about it, this is just a square root of 16, then cubed. That's it. That's all it ever is. Or if you're feeling really ambitious, do 16 cubed first, then square roots. What would you prefer to do? The first way or second way? First way, yeah. Well, 16, do you have 16 cubed off the top of your head?
Well,
No.
I think it's easier to like put it out that way.
Oh, sure, right.
If you have like.
Oh, sure,
For the second
right.
one, probably write it first.
But then mentally, you want to do it like, yeah.
Yeah.
Because what square is 16? And then multiply 4 3 times, which is what? 64. Yep. And as much as I love numbers, I would struggle with doing 16 cubed in my head as well. So I would much prefer to do square root first. But however you write it, yeah, either way is fine. Like if you want to, actually, and I'm with you, AJ. Like it is kind of cleaner to write it that way. But the computation in your head, try to do the radical first. Okay, next up, let's look at part B. Oh, doing the calculator. Do you see the exponent button? It's on the top right corner, I think. And then you got to put the exponent in parentheses afterwards. Yeah, I'll show you guys on Wednesday when I get my other laptop back. Okay, this is a negative exponent. So it's got to go on the bottom. And what's the index of my radical here? What root am I doing? I'm doing what kind of roots? I'm doing a fifth root, exactly. And then after I do the fifth root, what power am I raising to after that? 3, perfect. What do you get? One over 8, exactly. 1 out of 8. 100% correct. Perfect. Okay. What root am I doing here for part C? 4. Excellent. And then you're cubing the sucker after that. Okay. What do I get here? Exactly. Thank you, Alex. 27. So again, not that hard, but just an important skill to have, especially as you move forward in pre-calculus and calculus down the road. It's a good skill to have. Okay, let me just close this game. It's kind of annoying. All right, the next 3 have to use a calculator, unfortunately, but what I will do is just at least kind of show you that this is just a fifth root of 9, which I know is like 1 point something. By the way, you can take odd roots of negative numbers. You guys learned about imaginary numbers, I think, right after I left, right? But this is an odd root because 3 negatives multiply to a negative, right? So E will be okay, but you'll have to use a calculator for that one. And then this one here is 1 over the 4th root of 7, and of course then cubed. Which is going to be kind of weird, right? So fortunately, I did bring my calculator. So I'll just punch this in for time-saving purposes. Did anyone do part D? Did anyone get an answer they want to share? Yeah, I would say just to get guys in the good habits, probably run at 3 decimal places. I mean, you know me, I'm pretty lax about that kind of stuff. But just as a habit, I think like when you move forward in pre-calculus and calculus, especially if you do AP calculus 2 years from now, that's kind of the standard, 3 decimal places. So kind of just get in the habit of doing 3 decimal places. That's usually kind of good. Yeah, let's do 3. I didn't write these notes, so. But yes, you're correct, Hugo. Did say you should be a lawyer. So, but yeah, I think 3 is good. I'll see the next one. Now, next one, I could actually write it like this. If I put in the calculator, just make my life a little easier. I kind of like to do that instead. So if I put in parentheses -30 and then raise to the 2/3, you guys should get 9.655, I think. 9.655. And then lastly,
I kind of found it different way.
go ahead, Patrick. Yes.
I mean, if you just like put it in
Mhm.
as is, but you put positive 30 to negative.
Sure. Yeah, the reason it's the same thing because you're squaring afterwards. So negative would just go away, right? But if if that were raised to the 5th power, for example, then of course it'd be negative afterwards. So yeah. And then lastly, we're doing the 4th root of 7 and then cubed. I mean, you could just type in 7 raised to negative 3/4. You can just type that in. Or you can do the radical and then cube afterwards. We should get 0.232 for that one. Again, not terribly exciting problems, but just a good skill to have. So, questions so far? No, it's pretty straightforward. Okay, then we got some equations down below, I believe. Yeah, and then after this, I'll give you guys the classwork. And I do have to look at the grading and look at the instructional policy and syllabus. So I'll make that clear to you guys going forward by Wednesday. Today's my first day back, so just give me a day to kind of get my bearings straight. But what my expectation is that after we do a lesson, I want you guys doing some classwork problems. And I'll give you guys points for that, obviously, because I want to give you guys credit for it. And then there'll be homework I'll assign. The homework I'll assign will be some worksheet I'll put up in school. Just be some problems that you turn in. And if there's other things I may want to put up there, I might, like maybe a video perhaps. But I'll post homework by this afternoon. That way you guys get some practice at home as well, in addition to what you do in class. Let's look at G. Okay, so like any equation, we know your goal is to isolate x, right? That's like anything you do in math, right? Your goal is to isolate x. So whatever's connected to x, we have to properly, and I emphasize the word properly, remove those things to the other side, or move those things to the other side, so you get x by itself on one side, right? So let me rewrite the equation, but let me kind of do some stuff like this here. So let's look on the left side of the equation. You see an x, but there's two things connected to x. One has to be multiplied, and x is also being raised to the 4th power. Be careful here. This exponent, does it go to the x, or does it go to x and 1/2? Just the x. So some people will say, I want to do the 4th root first. You could, but then you got 4th root that 1/2 also, which makes it messier. I would not do that. What should be our first step for getting x by itself? Divide by 1/2, which is identical to multiplying by 2. Yeah, either way is fine. I would personally get rid of the 1/2 first, because it's going to make the math cleaner, right? Clean math is good. So multiply by 2, multiply by 2. Fortunately, cancel, easy peasy. x4 equals what on the other side? Okay, then you have to get rid of the exponent. How do I get rid of the exponent? You got to do the 4th root, because that's the opposite of the power, right? Exactly, do the 4th root. Ah, yikes. Let's do this instead. So what would x equal then if I do the 4th root of 16? So it's correct. Now here's where it's a little tricky though. Yeah, thank you, Hugo. We don't do this. So there's a difference. If you just do this, the answer is just 2. But when you do this, so this is a very important distinction. If I said, give me 4th root of 16, you said 2, great. If you said -2, that's not quite correct. I'll explain why in just a little bit. But if I give you an equation, and I ask you to take the 4th root, you do have to say plus minus 2. Why do I have to say plus minus 2 here? Because what if I put -2 back in? Does it work? Sure, -2 times -2 times -2 times -2 is 16, right? How come I don't put plus or minus if I just evaluate? So there's a difference. Evaluating, and let me type this up. When just evaluating an even radical, don't put plus or minus. But when solving an equation which requires even rooting, you must put plus or minus. Okay, hopefully you guys can read that. Sorry, it's a little small. So why? Why is that? So when you're just evaluating, you don't put the plus or minus, just give me the positive answer. But if you're solving, you have to put plus or minus. Why? Let me explain why. I'll erase all this because we don't need this anymore. Here's the reason why, and it's the reason is graphical, totally graphical. The reason why, and I'll emphasize this later in chapter 6 for sure, What I mean by that, you need the algebraic solution to confirm the graphical solution. The one thing I said, I think from day one, I think day one I did that little Star Wars thing where actually like we're learning all these different characters of Star Wars, have all these different equations to learn math. But really the big thing is helping you connect the graphical and the algebraic. We solve problems algebraically a lot, right? But we're also going to look at things graphically too. They have to be confirmed. Whatever you do algebraically has to be confirmed graphically. That way, you know you got the answer right, but it also deepens or enriches your understanding of these functions. Now you don't know how these graphs might look necessarily, but if you graph x to the 4 power, if I graph y equals x to the 4, it's going to look, if you go to Desmos, that's really your best bet. It looks like this. What if we graph y equals 16? How does that look, y equals 16? What kind of line would that be? But it would be horizontal, right? If I graph a horizontal, definitely linear, but more specific, it's horizontal. If I graph that, how many times does it touch the brown curve? And where would they touch? At what x values? 2 and -2, exactly. Exactly. That's why you have to give 2 answers when you solve. When you solve this equation, I have to give 2 answers because graphically it has 2 points of intersection. The points of intersection are the solutions. So can you put your phone away, please? Oh, thanks. Okay. Sorry, I thought you were texting. Sorry. So yeah, that's what we got. However, this right here. This you don't know yet. You will learn. You will learn later in this unit. If you graph y equals the 4th root of x, if you go to Desmos and we're to graph that, the graph looks like this. It just looks like that. That's the 4th root of x if you graphed it. And if you graph y equals 16, it looks like this. Now, how many times do those touch? And they touch it too. That's why you don't give 2 answers when you evaluate. When you evaluate a radical, it's not an equation you evaluated, you just give 1 answer. And because it has to confirm graphically what's going on. That's the reason why. So sometimes people get a little confused about that. I just want to clear that up with you guys. But that will become even more clear when we start talking about graphs at this later part of this unit. No, G is plus because it's an equation. Because it's an equation. But if I just add you find the 4th root of 16 straight up, you just say 2. But if you're solving, you have to give plus or minus. Assuming it's even. Assuming it's an even radical. So H, this one should be pretty straightforward. I think, hopefully. You could go about 2 ways. If you want, and I would never ask you guys to do it this way. I think you guys would wish I was still on paternity leave if I asked you to do it this way. That's kind of crazy, right? This is true. Because how many of these do I got here? These x minus 5s. This was multiply. You want to FOIL all this and work it out? No, I wouldn't do that. You could. You guys did polynomials, I believe, in your last unit, right? And you could solve it because like you guys talk about synthetic division and all that crazy stuff, right? You could do that. I wouldn't recommend that. That's if you like, like I'm using this freeway example. That's like if you want to get to San Francisco, well, let's go down to San Jose. Let's take Highway 280 down to San Jose. Let's connect with 680, then connect with 880, and then take the Bay Bridge over to San Francisco. That's nuts. Don't do that unless if the freeways are closed. Instead, I would do this. Oh. What should I do to both sides right now? Cube root, yes. Thank you, Matthew. Yes. Oh, come on. Here we go. Cube root. So x minus 5. Now, if you can't do this in your head, that's okay. I'd probably let you use a calculator for this, but it comes out as a clean number, by the way. Does everyone want to take a stab at what the cube root of -216 could be? Yeah, if you think about it, 6 times 6 is 36. If you multiply this by 6 again, 30 times 6 is 180, and 6 times 6 is 36. 180 plus 36 is 216. But you got to say -6. How come I don't put plus or minus, by the way? Yeah, because you can't have positive 6, because 6 multiplied 3 times is 216, not -216. So x is going to equal -1. There you go. Okay, last one, and then we're all done for the lesson today, and you guys can do. And what time we get up? 11:15? Okay. Crazy, I still remember that. All right. So we'll do some practice after this. What's your first step going to be here? Yeah, get that over to us. Don't do the fourth root just yet. That's crazy. Be clear and or be very methodical, organized with the math. All right. What am I going to do next? Fourth root. I like that. Fourth root. Very nice. Now, what's x minus 1 going to equal on the other side?
5.
Plus or minus 5. Yeah, it's got to be plus or minus because you're even rooting. Remember, we said if you're solving for even rooting, you have to put plus or minus. Because if you were to graph this, let me show you. If I were to graph y equals x minus 1 to the 4th power, that's going to look like this. If you go to Desmos, yeah, if you graph y equals 625, it's going to look like this. So you're going to get 2 answers.
Yeah.
So that's why we have to put plus or minus for even rooting.
Okay.
So what does x equal?
4, 6.
4, 6. X equals 6 or negative 4. Right.
Wait, what?
6 or negative 4. Is that right?
6 or 4.
No,
There's negative.
Yeah, age is right. 6 or negative 4. Yeah. Negative 4. 1 minus 5 or 1 plus 5. Let me erase the board so I still have it. Okay, cool. Okay, so what I like you guys to do now is some practice. And by the way, I'm not going to collect this practice until the end of the units, but I just want you guys working on the first page. That's it, just the first page. You can do it on here if you want, or do a separate piece of paper, whatever works for you guys. And then homework will be a separate thing. I'll send a homework assignment that goes with this. So this is where you guys are getting double the practice. You're getting some practice in class. In practice at home, I'll be reasonable. Be like 15, 20 minutes tops. No, then that's all I won't collect. So if you guys just work on the first page, that's all. I'll write the answers on the board. You guys can check your answers. And then after that, you're done. You can just relax. Talk about things we actually care about. I may not watch it, but
Only if Joe shows.
I change my mind. That's sweet. What's that? I'll slow it. No.
You're that?
Okay, you guys just work on the first page, please. And after that, you guys have the rest of the class chill out. I'll write the answers on the board.
And that's Rosser, and then LJ.
So I was so upset. And also my kids were just kind of bouncing around. So I was like, I'm not gonna watch this. And then yeah, then like a few minutes and I saw that live like it came 20, like 40 seconds watch. And that
It's all one.
you don't feel like it? You want
And
to
draws
that?
it was just, it was a little show.
But they don't like all that though. Always when you're out of bounds, they push it down. That's out of bounds.
After it.
I felt bad for that guy though. He was forward. Yeah.
I don't know.
But here's the thing, I mean, he still could have made the field goal for 55 yards perhaps, but it made it much easier, right? Yeah, it pretty much sealed Vegas' fate. It's just like, it's fine. Work that out.
Okay.
Yeah, what you have to do is like once over, but twice a month. Just do one over right away. Crazy. No, that's beyond you. Good. That's it. Whatever that is. So whatever. Okay, I'm gonna put answers up, guys.
It's what? It's one.
This first page, that's it. You're done. It's pretty easy, right?
You mean, yeah.
6 times 6 is.
Why can't they just not have?
No, but it's a square, it's a cube root. Well, it's not that's different, that's what it's.
Same exact amount.
No, what number? What?
Oh, it's rewriting, you're not solving or rewriting an expression.
Yeah.
This one is going to the bias. How do you know which number?
See, like I haven't lost my flash, I was able to do that in like 2 minutes, so.
It's on my objects.
Alright.
Then there's
Okay, let me stop the video. And as usual, I'll start sharing videos again too with you guys.